So this next category is exponential equations common base level 2. So we just did level 1, now we're going to do level 2. Okay, so it looks kind of crazy, but don't worry, we'll get through it. So we're going to solve for x, and let's take a look at this crazy number. We're going to have to figure out what base we want to write it as. And so to figure that out, we can look at the other side. We have this fraction, which I know scares a lot of people, but don't worry so much about the fraction. Take a look at the 49. I think you guys will know that 49 is 7 squared, right? And so that should be our clue that we want to write this with a common base of 7. So I'm going to write 1 over, actually, let me rewrite it as 7 first. So we know that 7 to the power of 2 is equal to 49. So then 7 to the power of negative 2 is equal to 1 over 49. Maybe that sounds familiar, maybe it doesn't, but we did learn this quite a while ago, so that's why I want to remind you that with a negative exponent, that's when you flip the fraction. So technically 49 is 49 over 1, so then when I say 7 to the power of negative 2, you flip the 49 over 1 and it becomes a 1 over 49. Before I go on, I'm going to pause the video, see if you guys have any questions. All right, so we figured out that the base that we want is 7. And so on the 1 over 49, that's 7 to the power of negative 2. Let's figure out what this thing is as the power of 7. So that's 1, 1, 7, 6, 4, 9 is equal to 7 to the power of something. Let's figure out what that something is. I'm going to use my calculator on my phone. All right, cool. So we just figured out that this should be 7 to the power of 6. And remember, I'm just doing that on my calculator because I don't expect anyone to know this off the top of their head. Okay, so now we have 7 to the power of negative 2 and 7 to the power of 6 as the things we're going to rewrite these as. So let's rewrite it. Instead of 117,649, I'm going to write 7 to the power of 6 to the power of x plus 14 is equal to, instead of 1 over 49, I'm going to write it as 7 to the power of negative 2 to the power of 5x minus 2. Okay, so let's rewrite this over here where we got some space, and remember that you are multiplying the exponent. So in this one, it's 6 times x plus 14, and then in the other one, it's 7 to the power of negative 2 times 5x minus 2. And then let's actually multiply them. So we have 7 to the power of 6x. What is 6 times 14? Let's take a look. 6 times 14 is 84. And then negative 2 times 5x. And then negative 2 times negative 2. And so this is what we have. So now we have a common base for both of them, that common base being 7. And so since we have them written with their common bases, we can now set their exponents to each other. So those are the exponents, the things that I just highlighted, and I'm just going to write them. Okay. And then let's solve for x. We're going to bring all the x terms to the same side, so I'm going to add 10x. That gives me 16x plus 84 is equal to, cancels, 4. And then I'm going to subtract 80. Sorry, I'm writing over the words, I know. Oh, sorry, not 80. I don't know. I took away the 4 already. So 84. Okay, so minus 84. And then we get 16x equals negative 80. That's where I got the 80 from. Sorry, my bad. And then we're going to divide by 16, divide by 16. I'm going to write it to the side because that's where I have space. And then I get, cancel out, x equals negative 80 divided by 16 is negative 5. I feel like we've gotten negative 5 as our answer quite a few times now. But yes, this is our answer. I'm going to pause the recording, see if you guys have any questions. So let's save this and type negative 5. Oops, that is not a negative 5. Negative 5. There we go. Okay, let's do a few more. So I think for exponential equations common base level 2, I believe we're going to have to rewrite all of these to have the common base. Like we'll probably have to rewrite the 64 and the 256. So let's go ahead and do that. So I think I want to try the number 2. Let's just try with 2 because they're both even numbers. So I'm just going to try with 2. Okay, so let's see. 64 is equal to 2 to the power of something. Let's figure out what that something is. And we also have 256 is equal to 2 to the power of something, and we're going to figure out what that something is. So I'm going to pause the recording and try it out on my calculators. Okay, so I found out that it's 2 to the power of 6, that gives us 64, and 2 to the power of 8, that gives us 256. But this is a 1 over 256, right? And so remember that this is technically 256 over 1. So if I want to flip the fraction, then I must write 2 to the power of negative 8 instead of 8. Being positive, it is now in 8 being negative. And that allows me to flip my fraction by 256 over 1 into becoming 1 over 256. So we have a negative exponent. So anytime you have a fraction, you want to make it a negative exponent. Do you guys have any questions? All right, so let's rewrite it all. I'm going to erase this arrow just because kind of in the way. Okay, so instead of 64, I'm going to rewrite it as 2 to the power of 6. And then instead of 1 over 256, that is 2 to the power of negative 8. And let's write it out. Remember, we are multiplying the exponents. So 6 times x minus 2. And negative 8 times x plus 12. And so let's actually multiply them out. So 6 times x is 6x. 6 times negative 2 is minus 12, and yet I wrote something completely different. Minus 12, there we go. And then on the other side, multiply it out. So negative 8 times x is negative 8x. And negative 8 times 12, can't be bothered to do that right now in my head. So 8 times 12 is minus 96. All right, so now we have written them with their common base, the common base being 2. So now that they are written with their common base, we can take the exponents and set them equal to each other. So then we'll have 6x minus 12 is equal to negative 8x minus 96. Let's see, do I have enough space there? No, let's just rewrite it over here. More space. I'm just rewriting it. Okay, so let's solve for x. And to do that, we're going to bring the x's to the same side. So I'm going to add 8x, add 8x. This gives me 14x minus 12 is equal to cancels out, negative 96. And then we're going to add 12, add 12. We get 14x, cancels out, is equal to negative 84. Then divide by 14, divide by 14, cancels out, x is equal to negative 6. All right, so our final answer is negative 6. So let's go ahead and enter this in. Let's do some more. Okay, and so we have large even numbers. So you know the drill. When it's even, I'm going to test it out with a base of 2. So let's figure out, this is 2 to the power of what? And that is 2 to the power of what? So let's see, 262,144 is equal to 2 to the power of something. Let's figure out what that something is. And I'm just going to try it out with 512 first. 512 is equal to 2 to the power of what? So I'm going to pause the recording and then see what this gives us. All right, so I found out that 262,144 is equal to 2 to the power of 18, and 512 is equal to 2 to the power of 9. But then, of course, this is a fraction, 1 over 512. So technically, we have to flip this 512 around. So that means 1 over 512. The flipped version is equal to 2 to the power of negative 9. Remember, it's a negative now because we just wanted to flip our fraction. And 512 is a fraction, it's just 512 divided by 1. So if you want to flip that fraction, you just make it a negative exponent. All right, so now that we know that they are both 2 to the power of something, then let's rewrite it with its common base. So instead of 262,144, I shall write 2 to the power of 18. And then instead of 1 over 512, I'm going to write 2 to the power of negative 9. So, of course, if you found a different base that works, like maybe you tried something else, I don't even want to come up with another number, and it works, and that's fine. But remember, you just double check on your calculator. Literally, if 512 is equal to 2 to the power of 9, then that's good, and 262,144 is equal to 2 to the power of 18, then you have a common base of 2, and that's good enough. Like, my common base might be slightly different from yours. In this case, I believe looking at it now, we could have used a common base of 512, but that's okay. We used 2. It still works. Okay, so from here, let's multiply out our exponents. So we have 2 to the power of 18 times x minus 2. 2 to the power of negative 9 times negative 3x plus 3. So we just multiply our exponents. I'm just going to double check that I wrote everything right. Looks like it. Okay, let's multiply it out. 18 times x is 18x. 18 times minus 2 is minus 36. Negative 9 times negative 3x is positive 27x. Negative 9 times positive 3 is minus 27. So now we have a common base of 2, therefore we can set our exponents equal to each other. So then we have 18x minus 36 is equal to 27x minus 27. So solving for x, let's bring all the x terms to one side. So I'm going to subtract 18x, subtract 18x. Those cancel out. We get negative 36 is equal to 9x minus 27. Okay, wait, I forgot to pause. Are there any questions up till here? All right, next is to bring the 27 over there. Those cancel out. Wow, I did not really leave myself much space here. So 9x, I'm just going to write it lower because I don't like writing over the words because I think it's hard for you guys to see. So 9x and then negative 36 plus 27 is negative 9. So let me just rewrite that over there. So we have negative 9 is equal to 9x. Then we divide by 9. We get x is equal to negative 1. So this is our final answer. Any questions? So we're going to save that, type negative 1 into our answer box. Okay, so we did 3 examples here. I believe that should be enough since you guys didn't have any questions. So let me know if you do need more help in the breakout rooms.